guys, so today we're going to look at operations with polynomials. So we're going to add, subtract, multiply, and divide polynomials. Add, subtract, and multiply is actually nothing new. This is really just review. But once we get into division, that's the part that's going to be a little bit newer. All right, so just reviewing some of our notation, g plus h of x means we add the g of x function to the h of x function. So 4x squared minus 5 plus 7x cubed minus 3x squared plus 4x minus 5. Combine your like terms, and whenever we work out these problems, we're going to write our answers in standard form. Standard form, remember, our exponents go in order from biggest to smallest. So this would be 7x cubed plus x squared plus 4x minus 10. All right, with subtraction, again, very similar process, but a really common mistake. We need to remember that when we subtract, so this is f of x minus h of x. When we subtract the h of x function, we are subtracting the entire function. So I'm going to put it in parentheses so that I remember that I am subtracting that whole function. Typically, when you guys see the parentheses, you do a pretty good job, but a lot of times you forget to include those parentheses because we are subtracting the whole function that follows. So I'm going to rewrite this with that negative distributed. So this is minus 7x cubed plus 3x squared minus 4x plus 5. Then it's the same problem as before. Combine like terms, write it in order with the highest exponent first, and we're done. All right, moving on to C. This is multiplication, so f times g of x. So whenever we multiply polynomials, it's a very similar process to FOILing, but sometimes we're going to deal with terms that are more than just binomials. So if that's the case, we need to make sure every term on one polynomial gets multiplied by every term in the other polynomial. So if I start with 3x squared, that gets multiplied to both terms that follow. Whenever we multiply, remember, with exponents, if we have same bases, something like this, we would add those exponents together. Okay, so multiplying with our exponent bases, you add the exponents together. So this would be 12x to the fourth minus 15x squared. And then we go on to the second term. Minus 8x cubed plus 10x. Then we'd have plus 4x squared minus 5. Then we'll go ahead and combine our like terms together. Go in order from highest degree to least degree. So 12x to the fourth minus 8x cubed. Combine our like terms together. And we have our polynomial. All right, the last one, again, this is really just a review of the notation. F of g of x is how I read that. That's a composition question. That means the g of x function is going to replace every x in the f of x function. So if I want, I could actually rewrite this as f of 4x squared minus 5. So in the f of x function, I'm replacing x with 4x squared minus 5. That's the g of x function. And then from here, I'm just doing the operations. So a few things to keep in mind when you do this math. PEMDAS order, okay? This has an exponent. I cannot distribute that 3 until I have taken care of my exponent. So I have to do 4x squared minus 5 squared first. Next big mistake, remember, 4x squared minus 5 means 4x squared minus 5 times 4x squared minus 5. So you either need to FOIL that whole thing out, or you need to remember that little square double square shortcut we talked about. So we square the first, we multiply and double. So negative 20x squared doubled times 2 is negative 40x squared. And then we square the last. So square, double, square. Don't just square those two parts. This is your answer is a trinomial. It's square, double, and then square. Then we can go ahead and distribute that too because there is no exponent. It's just a normal set of parentheses. So that's minus 8x squared plus 10 plus 1. Now we can go ahead and distribute that 3 because again at this point it's just a regular old set of parentheses. I'll go ahead and combine those terms together. Then again, combine like terms one last time. And I'm done. All right, so now we're going to move on to division. So in order to do division of polynomials, we need to remember how we do actual regular old long division, like you learned back in elementary school. So just some vocab, okay? This is our divisor. This is our dividend. The divisor is the one that goes outside the little house. Inside the little house, we've got 3, 1, 2, 7, 2. Then the way we figure this out, all right? 5 goes into 31 6 times. We multiply, then we subtract. Then we bring down the next number. Then we do it again. 5 goes into 12 2 times. 2 times 5 is 10. Then we subtract. Bring down the next number. Do it again. Subtract. Do it again. Now at this point, you probably learned a couple of different things. 2 is our remainder. But you probably learned where you put a decimal here and a 0 and you bring down the 0. We're not going to get into that though, because there's another way you can write your divisor. If you continued with that decimal, you'll notice you would have gotten 0.4. We also can write the remainder as a fraction over the divisor. So I also could write this as 6,254 and 2/5. 2/5 is the same thing as 0.4. And that's what we're going to use for these polynomials. We're going to write the remainder as a fraction over the divisor. All right, so let's go ahead and actually try a long division question. So we're going to set this up the same way. X squared plus 3x plus 1, and that goes into 4x cubed plus 2x squared plus 3x plus 5. So in order to figure out the number that goes at the top, all we're going to look at for that number is just these first two terms. We don't need the perfect number for all three of these and all three of these because we're not going to find it, and we're going to have to subtract anyway. So looking at those first two terms, x squared times 4x gives me 4x cubed. So that's my number that's going to go up at the top. Now one thing too that I do a little different, I don't just write it in front of this one. I go ahead and keep all of my terms lined up, all my x's together, my squareds together, my cubes together. It just helps me. If you want to write it over here instead, go ahead. All right, so once you have a number written at the top, you take that number and you multiply it by every term that's over here on the left side. So I'm going to take 4x times x squared, 4x times 3x, and 4x times 1. Then in long division, our next step is to subtract. This is where all the mistakes happen because remember, you are subtracting that entire polynomial. So what I like to do to remember that I'm subtracting is the same as adding the opposite. So I went ahead and changed this to plus and then just change all of my signs. Then I can go ahead and just combine these, and it's easier to remember that I've subtracted. Then I bring down the 5, and I do it all over again. So I look at just the first terms. Well, x squared times negative 10 is negative 10x squared. Once I get the number at top, I multiply it by all three terms that are over here. So that's negative 10x squared minus 30x minus 10. And then I subtract everything that follows. So subtract, I'm going to change it to plus, change all my signs. This is 29x plus 15. At this point, you'll notice what I have down here is a lower degree than what my divisor was. Once you have a lower degree here at the bottom than the divisor, then what you have left is your remainder. And again, we're going to write the remainder as a fraction over the divisor. And that's my answer. All right, so again, it looks a little bit complicated, but it's the same process that we've done just with regular old long division. Just be careful on your subtraction. That's where it's easiest to make the mistakes. All right, so let's try another one here. So again, I'm going to have x squared plus 2x minus 5, 6x to the fourth plus 5x cubed. And before I continue writing this, one thing you'll notice, if you look at your exponents, one of our terms is skipped. I've got 4, 3, 1, 0. I don't have any x squareds. So I'm going to go ahead and fill in a 0x squared just to help me make sure I keep everything in line. And then I'm going to do the whole thing all over again. So we're going to look again at our first terms. So x squared times something is 6x to the fourth. Or 6x to the fourth divided by x squared is what? And that gives me 6x squared. So what I get, I'm going to take that and multiply it by every term on the left. So that's 6x to the fourth plus 12x cubed minus 30x squared. Then I'm going to subtract the entire polynomial. So again, I'm going to change the signs. I'm going to change it to plus, negative, negative, positive. So this is negative 7x cubed plus 30x squared. Bring down the 2x. Then we do it again. X squared times something is negative 7x cubed. That's going to be minus 7x. Multiply that by everything. And then we're going to subtract again. And again, when I subtract, I'm going to go ahead and change all my signs. So I'm going to change this to plus and change my signs. So this becomes 44x squared minus 33x. Bring down the plus 8. Then I'm going to do it again. Okay, x squared times 44 is 44x squared. And then I'm going to subtract. And in order to subtract, I'm going to change my signs. So I get negative, that's going to be 121x plus 228. At this point, I'm at a lower degree. Since I'm at a lower degree, what's left is my remainder. I write my remainder as a fraction over the divisor. All right, so we're going to do one more example of long division. If you feel pretty comfortable, go ahead, pause the video, and try this one on your own. All right, so x minus 3 is on the outside. Then I have 2x cubed minus 6x squared plus x minus 4. X times 2x squared would give me 2x cubed. So I'll multiply, subtract, change my signs. And this time you'll notice those x squareds cancel out. So I'll go ahead and bring down the x. I'll also go ahead and bring down the minus 4. And then we just do the same thing again. This is the same degree, so we can still keep going. Look at our first terms. Well, x times 1 is x. Multiply, subtract, change your signs, and I get a remainder of negative 1. So this would be 2x squared plus 1. And again, we write the remainder as a fraction over the divisor. So on this question, we're actually going to look at another method we can use for division. Now this method's a little bit faster, most people like it a little bit better, but it only really works in certain cases. And that case is when we're dividing by x plus or minus a number. So if you're dividing by x minus 3, x plus 7, x plus 10, x minus 6, then we can use synthetic division. So the way synthetic division works, we're going to start with a number in a box in the top left corner. That number is the 0 of what we're dividing by. So it's the opposite sign of that factor. So if you're dividing by x minus 3, positive 3 goes in the box. Then what we do is we're going to list the coefficients of the dividend. So if I'm working out this same problem, I'm just going to list those coefficients. So 2, negative 6, 1, and negative 4. Then the process, we start with the first number and we just bring down that first number. We don't do anything with it. Then we're going to do the same thing for everything else. I take the number at the bottom, I multiply by my number in the box, and I write it in the next spot. Then I add down the column. Then I take the number at the bottom, multiply by the number in the box, and I add down the column. 1 times 3, multiply, add down the column. The last number that you get is the remainder. And if you notice, there's a correlation between the answers we got here and what we got when we worked out with long division. So the way this works, your answer is the numbers that you have are the coefficients of your answer. you start 1 degree less than the original dividend. Well, this original one was 2x cubed. So since that was 2x cubed, we're going to start 1 less than that, which is 2x squared. And this would be regular x, and that would just be regular 1. So our answer here is 2x squared plus 1. We still write the remainder as a fraction over the divisor. All right, let's try a couple more synthetic division questions. So if I'm dividing by x minus 2, positive 2 goes in my box. Then I'm going to write my coefficients. And again, you'll notice there is no x squared. Anytime a term is skipped like that, you have to fill in that 0 for synthetic division. It's helpful for long division, but it is necessary for synthetic. You'll get the wrong answer if you don't. So this is going to be 2, then 0, then negative 5, then 8. So I start by bringing down the first number. I multiply by what's in the box, and I add down the column. Multiply by what's in the box, add down the column. Multiply, and add. Last number is the remainder. Then the other numbers, the coefficients, we start 1 degree less than the original. Well, the original was x cubed, so this is going to be 2x squared plus 4x plus 3. We write the remainder as a fraction over the divisor. All right, let's go ahead and look at the next one. This time we're dividing by x plus 1. So again, it's still the opposite sign in the box. So that means negative 1 should go in the box. That's probably one of the biggest mistakes. The biggest mistake is forgetting to do the opposite sign. The other big mistake is forgetting the zeros. All right, so then if you feel comfortable, pause the video and try and finish this one on your own. All right, so my coefficients are 2, 0, because there's no x cubed, negative 4, 2, and negative 3. Bring down the first, multiply and add, multiply and add, multiply and add. Last number is the remainder. We start 1 degree less than the original. The original was to the 4th, so this is going to be 2x cubed minus 2x squared minus 2x plus 4, and remainder is a fraction over the divisor. All right, the last thing we're going to look at are just 2 applications of synthetic division. One of these is really going to help us out next week. So what we're going to look at, we're going to evaluate f of negative 2. So it says to use synthetic division. Well, to start, I just want to evaluate f of negative 2 the same way we've always evaluated f of negative 2. Just plug in negative 2 for x. So if I do that, I can still get my answer. There's nothing wrong with doing this way. It's still going to work. So that would give me 4 times negative 8, 3 times 4, combine all those like terms together, and I get a negative 23. That method still works. But what's really nice about synthetic division, that gives us a different way to work this out that sometimes can be easier if you don't have a calculator based on the numbers that you have. So what I'm going to do is use synthetic division with negative 2 in the box. I'm not going to change the sign because I don't have a factor here. I just have the number. So use the same number, and then I'm going to write those coefficients. Go ahead and do synthetic division. And if you notice, when I evaluated f of negative 2, this is the answer I got. That answer is the same as the remainder when you do synthetic division. So that's just a nice little trick with synthetic division, which is something that can maybe help make some of the math a little bit easier for you if you don't have a calculator. Now, what's really important about this is the application it has in the next example. So if I want to determine if x minus 5 is a factor, well, let's think about what that means. If x minus 5 was a factor of a quadratic, then I could find the zeros of that quadratic, or the x-intercepts of that quadratic, the solutions to that equation if it was equal to 0. Okay, whichever way I'm working it out, if x minus 5 was a factor, 5 was an x-intercept, 5 was a solution, 5 was a 0, 5 was a root. The reason we call it a 0 is because when I plug in 5 to that equation, it equals 0. Well, using what I know about synthetic division, if x minus 5 is a factor, when I plug in 5, I should get an answer of 0. That means if I do synthetic division with 5, I should get a remainder of 0. And since I do, that right there is proof that yes, x minus 5 is a factor of that polynomial. And this is going to be really important for us next week because we're not just going to use that, we're also going to use those remaining numbers to tell us some other information. But that's what's coming up next week. All right, so that is it for operations with polynomials. Just make sure you get some practice in with both long and synthetic division.